Welcome to 24 Hours of PASS Summit 2015 preview. We're excited you could join us today for John Welch's session, Advanced Scripting using SSIS Script Tasks and Components. This 24 Hours of PASS event consists of 24 consecutive live webcasts delivered by expert speakers from the PASS community. This session is a preview of one of many technical sessions that will be presented at the PASS Summit in October this year, including my own session on baselining. Recordings will be available in around about 1 week at www.24hoursofpass.com. My name is Richard Douglas. I'm a sales engineer at SQL Sentry, and I've got a few quick introduction slides before I hand over the reins to John Welch. He's going to speak for about 40 to 45 minutes, and then what we're going to do is we're going to move on to the Q&A section where you can ask him any questions that you might have. If you do have any questions or you experience any issues, just type your questions into the question pane on the GoToWebinar control panel, which you can see on the slide here, and someone will be able to assist you. Feel free to enter your questions into the Q&A field at any time, and once we get to the Q&A portion of the session, what I'll do is I'll read off the questions to the speaker, since all of you guys are actually going to be muted throughout the call for sound purposes, and what you would need to do is you'll need to submit these questions by typing in the Q&A box. There's also going to be a short evaluation session at the end, and your feedback is really, really important to us, especially the speakers. So please do take a moment to complete it, and it's going to appear in the web browser at the end of your session. Now, 24 Hours of PASS wouldn't be possible without the support and dedication of our sponsors. They're the real reason that this event is available for you guys free of charge, and everybody loves free stuff. So I'd like to take a moment to thank all of our presenting sponsors, which are Microsoft, Dell Software and Idera, and in addition I'd also like to thank the supporting sponsors for this event, which are HP, SQL Sentry and Pyramid Analytics. So next what I'd like to do is to bring your attention to the upcoming PASS Summit, and this is taking place in Seattle, Washington, and it takes place from the 27th to the 30th of October this year. Now, PASS Summit 2015 is going to feature over 200 sessions with some world-class SQL Server experts there and lots of Microsoft staff there, so they'll be able to answer all of your questions. Now, this event is planned and presented by the SQL Server community for the SQL Server community, and the PASS Summit is the largest gathering of SQL Server and BI professionals on the planet, so it's well worth attending. It draws in over 5,000 registrants from all over the world, and the PASS Summit really is a great place to network. I can wholeheartedly say that, and you do get to meet face to face with expert peers, MVPs. I mean, I've even spoken to Connor Cunningham there. It's a really great opportunity to network. But more importantly, the PASS Summit delivers on providing you with answers to your SQL Server issues, along with the knowledge, strategies and skills you need to stay ahead of the learning curve. Right now you can save $200 by using the discount code 24HOP15, that's 24HOP15 when you register, and you can optimize these savings by registering before the end of Sunday, September the 20th. To find out more about the PASS Summit, visit www.passsummit.com, or you could also go to www.sqlpass.org, and there's a banner on there for that. Now, what we'd like to do is to make sure that you guys explore everything that the PASS has to offer for data professionals. So you can log on to www.sqlpass.org, and you can find out where your local user groups are around the world. You can join various virtual chapters, you can find free online resources through our Learning Center, and you can read up on the latest community news in the Connect newsletter which comes out. For those of you that are more interested in business analytics, you can check out the PASS Business Analytics Conference, which happens in May next year, and you can visit www.passbaconference.com, that's passbaconference.com, for more information or to subscribe to the bi-weekly BA Insights newsletter. So without further ado, what I'd like to do is to present the speaker of the hour, John Welch. John works at Pragmatic Works, where he manages the development suite of SQL Server products. John's worked with business intelligence and data warehousing technologies since 2001, and he's a Microsoft SQL Server MVP. He's a frequent presenter on SQL Server topics. In fact, we were talking about just that and the SQL Saturdays that he contributes to, as well as contributing to several open source projects, including SSIS Unit, which is a unit testing tool for SSIS. So without further ado, I'd like to hand over to John. Take it away, John.
Okay. Thank you, Richard. Really appreciate the introduction. So hopefully, I know it's depending on what time zone you're in, it's either late at night or fairly early in the morning. I've had plenty of coffee. Hopefully everybody else has, and everybody will stay awake for the session. So today we're going to be talking about advanced scripting using SSIS, focusing in on script task and components. This is a preview of the session that I'll be giving at PASS, so you'll see some of the slide content. We're trimming out several of the more advanced demos just for purposes of fitting the content into the time block that we have. So just a little bit about me. Richard already did a fantastic job introducing me, so I won't go through much of this. Most important information on this slide is the contact information. So you can see my blog at agilebi.com/jwelch. This has actually a fair amount of scripts that I've developed over time posted out there already, so a good resource for looking at those types of things. In addition, you can reach me on Twitter, or probably the most direct method of getting in touch with me is via my email at jwelch@pragmaticworks.com. So we're going to talk today a little bit about script task and show an example of setting up a script task. We're going to look into script components, talk a little bit about how we can handle asynchronous components, both in the data flow, a few tips and tricks for creating your scripts, and then finally keeping it dry, which is one of the principles from pragmatic programming, which is don't repeat yourself. So we'll jump right in with the script task. Script tasks are kind of the Swiss Army knife when it comes to SSIS. They let you do pretty much anything you want to do. Because they are a Swiss Army knife, there's not a lot of structure provided for the script task. So you have the flexibility to basically write your own program in the scope of the script task. All it really does, as we'll see as we get into the demo, is provide you with a placeholder that lets you write some code to do whatever you want to. The common reasons for using script task, primarily it's when you need to interact with something external to your package. So this might be doing something such as interacting with the file system to retrieve a list of files. It might be going out to a secure FTP site to download it. It might be interacting with a database to run queries for something that doesn't support a standard OLADB or ODBC provider for it. So we're going to jump right in, again, kind of bright and early, and get into a little bit of code to hopefully wake everybody up. So this is a script task that is designed to produce an ordered file list. The scenario that I often find myself using this in is I'm getting a set of incoming files from some third party that's FTPing these, copying them to a network share or something like that, and I need to make sure that the files are processed in the order that they were received. So what we're going to show is first how we get that list of files, how we can easily order them and filter them down to just the ones we're interested in, and then pass them back to the package so that we can enumerate over them. So a couple of the key things that you'll see in this are the use of the file IO namespace in .NET, and also link for manipulating list. A couple of key things to remember with this: there are ways to do this without actually using a script. For example, you can get files off disk and enumerate them using the for each container using a file enumerator. However, that doesn't let you order them. So you're relying on the order that the file system returns them back in, which is not actually guaranteed. So as a general thing, it's always good if you want something in a specific order, just like doing a select statement, you want to have an order by clause on those. In working with the file system, you need to make sure that it's ordered in the way that you want them. So let's switch over to our demonstration. So here we are looking at a package. Our script task is here, getting the ordered file list, and there's a couple of key things that we want to look at here. One, we're passing in a variable for a file mask, so this lets us basically choose what types of files that we want to include or exclude. The folder path, this is the folder that we actually want to enumerate the files out of. And then a read-write variable file list, this is for the resulting list of files that we produce. So just to show everyone the variables very quickly. So we have those defined. As the file list is going to be an object because we're putting a collection into this. And the file mask, simple string, we're going to look for just text files. And the folder path is in our demo advanced SSIS scripting folder. And file path is a variable that will populate in the step after we do the script. So let me switch back here and we will open up the script. One of the most joyous parts of working with scripts in SSIS is how long it takes the editor to load. It doesn't seem to matter how many times that you have opened it or whether you've opened it recently or not. It pretty much consistently takes a good bit more time to open than it seems like it should. And let me just increase the size of my fonts a little bit for presentation purposes. Okay, so when you create a new script, script task I should say, what you end up with is basically this public void main function, no content here. I'm assuming that since this is an advanced presentation, you've probably already seen that at some point and written at least some simple code. So what we're doing here, I won't spend a lot of time elaborating on those pieces, but happy to take questions on that after we get through the presentation. But what we're doing here is actually grabbing the folder path that we looked at earlier and the file mask. And we're using the directory object. Again, this is contained in the system IO namespace, as well as we're going to use some things from the system.link namespace. So for that, we're using the directory object, verifying that the directory that we're trying to enumerate actually exists. Always important to add error checking to your scripts, and I like using the DTS events methods, in this case fire error, to actually report these. That ensures that it's logged to your package like any other error would be. Great when things are in production and they don't work exactly as you expect them to work. The information will show up and follow the standard logging for your package versus writing to something that won't be necessarily visible in your standard logging. So a key part of working with scripts, particularly from an advanced standpoint, you start doing more complex things, error checking is very important. So you have to try to anticipate what might go wrong, make sure you check for that, and log it. Troubleshooting scripts, particularly in production, can be very challenging. So ideally you have good error checking that lets you see this is where things took a left turn and didn't go down the path we were expecting. So as long as the directory exists, we keep running. Here we're just going to enumerate the files in the directory, passing in that folder path that we specified, as well as the file mask, so that we only get files matching the star.txt file mask that we specified. So then we're going to use link. Out of this we get the directory enumerate files returns us a list of strings. So we're going to use a link method. Link is full of objects that are great for working with lists of things. They really simplify the code to do this. So in this case, we're basically selecting from the existing list, which says effectively enumerate over every item in the list, and I'm basically passing that in to a new file info object. The item in this case is going to be the string representation of the file path, so that's going to create a new file info object from that. That gives me this file object list, and then I can take that resulting list and put it in a new list by ordering by the item's last write time. So this gives me the modified date. So 2 lines of code to effectively translate all my strings into file info objects and then order them by last write time, which is the ordering that I want to use for this. And then finally, I can select that ordered list back out using another select, using the full name of the file info object, which again is the full path for that particular file. And in this case, I'm inserting that into that file list object variable that we defined earlier. So this ends up being essentially at the end of the script processing a collection of file path strings, but ordered by their last write time. So, and then we want to return script result success so that SSIS actually knows that things work the way they were supposed to. And we will cancel out of this and take a look at the enumerator. Simple for each loop container. The collection, in this case, we're using a for each from variable so that we can point to the file list variable that we already defined. So the nice part about this is it will work against any type of collection object. So a list, a dictionary, any of those types of things. And then we're simply just mapping the string to our file path variable. And we can run this and see the results of the ordering. Fairly quick to run. And here you'll notice we have, just zoom in on this a little bit. You'll notice that we have the sample 2, 3, and 1. These are ordered by the actual create date time. You'll have to trust me on that, but not the normal name ordering that you get typically when you order from the file system. So, okay, so again, script task, relatively easy to work with. There's not a lot of constraints on what you can do in it. Basically, if you can put it inside the main function, you can do it. Very possible to write complete programs as part of script task, even though typically that's not really the best way to approach it. You generally want to keep your script task relatively concise and focused on solving one particular problem. Okay, so we're going to switch back to the presentation now and switch over to script components. So script components are a little bit different than script task. Again, script task, kind of a Swiss Army knife. Script components are a little bit more dialed in specifically on data processing. When you create a script component, you have 3 options for it. It can either be a source, a transformer, or destination. These work just like a source, transformer, destination inside of the data flow as far as what their primary focus is, either pulling things into the data flow, saving or pushing things out of the data flow, or modifying the data that's flowing through the data flow. Script components have a lot more structure to them. So they have a very specific series of calls that are made. Tends to be a little bit more work, particularly if you want to do something that's a little bit more complex in those. But the structure also makes it easier to get in and write something that's focused on data transformation. So we're, again, not going to spend a ton of time just talking about it. Instead, let's get in and look at a couple of demos. I want to first show capturing running totals. So again, with most of these things, there's multiple ways to do this. Running totals, you can capture using windowing functions in the SQL Server later releases. There's other mechanisms for doing this. Reasons why you might want to put it in a script component versus trying to do it through T-SQL or something like that. Well, perhaps you're working with a data source that's not T-SQL. So there's always the option of landing the data inside of SQL Server or some other database that supports windowing functions and doing the calculations there. But in a lot of cases, if you're reading in from a flat file, it's faster to just process the data as it's coming in versus having to land it somewhere else and then reload it to do additional processing to it. Those things are all very much driven by your environment and what's the constraints that you're working under. The other nice thing about doing it in script component is it is more portable. So if you do it there, even if you need to change out the source that the information is coming from, the running total calculation just stays in place because it's doing it as part of the data flow itself. So what we're going to do here is really show in a script component how you can do something above and beyond just simple, I got a row of data, I'm performing an operation on this row, and now I'm moving on to the next row, and I've forgotten everything about what just happened. Instead, we're going to actually cache some values to use across rows. We're going to check to determine when we need to reset those accumulators and basically demonstrate how those pieces work. So let me switch back over to Visual Studio. And we'll go to our running totals package. So simple package, single data flow. The data flow source is just a OLADB source that's pulling in a list of employees. And we're going to run it through a script which calculates the running total values. So the script setup a little bit more complicated than for components than it is for task. There's a couple of interesting things that we need to do. We need to make sure we select which input columns from the upstream components are actually going to be used by this script, and also what their usage type is. Some people will come in and select every input column. Generally, that's not the best approach because there is a certain degree of overhead in selecting more input columns than what you actually need. It's not terrible, so you're not necessarily going to see enormous performance improvements by this, but in the interest of not increasing overhead where you don't have to, I do recommend only adding the specific columns that you need to work with. In addition, there's a little bit of difference between using read-only and read-write. So you typically want to take just the usage type that you actually need. In this case, we're not modifying the salary, we're not modifying department. We're simply using those values in order to calculate our running totals, so we can bring in both these columns as read-only. Now under outputs, we've actually added a couple of new columns, and these are columns that are going to be populated by our script, one for the running average of the salary, and two for the running total. So I will go back and actually edit the script here. And again, we'll have that nice delay while we wait for the scripting environment to come up. Okay, so hopefully everybody can see that now. So again, the script, a little bit more complicated. One of the things that you'll notice with the script, there tends to be a lot of boilerplate in it. This is perfectly fine to get rid of. Anything that's in comment blocks, for example, if you don't need to see the comment on how to interact with a variable from within the script component, just delete it. Doesn't modify anything or won't harm anything. The things that you really want to make sure you leave alone, the component entry point attribute, the name, etc. These are things that get referenced from outside of the script itself. So modifying these things can actually break your script component. So as a general rule, leave those alone. So what we're going to do in this one, we need a couple of instance level variables. So you'll notice these aren't inside the process input row method. They're declared at the class level. So this means they persist for the lifetime of this particular script component. And they are going to capture a few values, the current department ID, the running total, salary, the running average, as well as an employee count for each department. So what we got when we created this, we picked a transform type, so it pre-filled out the fact that we're really just looking at processing input rows. I'll show a little bit more detail what happens behind the scenes with this a little bit later in the presentation. But for now, just when you create the script component, some magic happens behind the scenes, and it creates a set of objects that let you interact with the row itself in a fairly easy fashion. So what we want to do in this script, first off, we want to check to see, is the row we're processing for a new department, or is it for the same department? This does require that your input is coming in an ordered fashion, in this case ordered by department ID. So I didn't show this, but in the source component, we're actually doing an order by department ID to make sure that things come in sorted properly. If you don't do that, you'll get some really weird results out of this. So if it is a new department, so our current department ID is not equal to the current row's department ID, then we're going to reset all of our counters back to 0. We're going to set the current department ID to the new current value for that. And then we're good to start accumulating values again. So to accumulate the values, we simply increment or do some math on the instance variables that we are defined in up above, the department ID, running salary total, etc. And then we're doing our average calculation. This is the plus equal, if you're not familiar with C#, is simply saying take whatever the current value is of running salary and then add the row.salary value to it and assign that back to the same variable. So it basically gives us a running total there. And then we're taking those values that we just calculated and copying them to those output columns that we defined. So the key thing about this is we're actually caching the value between rows so that the totals actually will accumulate. A lot of uses of the script component, you simply see manipulation done directly on that row, and then that's it. Using the instance variables gives us the ability to persist values over the lifetime of the component. So, okay. One of the other things, in this case, we can write to our output rows fairly easily. We can also write to variables, but if you want to write to a variable on the package, you can't do that in process input row. Instead, you have to do it in the post execute function. So the reason for that is writing to a variable at the package level for every row just means that every time you process a row, that value is overwritten. There'll never be anything able to take advantage of the value that you're writing in the interim. So by putting it in the post execute, you just write the value once. It's one, much more efficient from a processing standpoint, takes a lot less time. Two, it avoids any weird errors you might get by the state of the variables at the package level being modified on a per row basis for within the data flow itself. So we'll go ahead and close this, run it real quickly so that we can see the results. And we simply have a data viewer here that takes the input values that we had, salaries, departments, as I mentioned, sorted by that, and does the running totals as well as the running average. And I won't bore everybody with the sitting down with their calculator and adding all these up. I've checked, and yes, they do produce the right results. So we'll go ahead and finish that and stop this particular package. Okay. So again, an example of how you can actually cache information between rows while processing in your data flow and use those for subsequent manipulations. Let's see. So the next one that we want to talk about is dynamic business rules. So this is a request that comes up with a fair degree of regularity around SSIS. Is how do I make things more flexible and changeable without having to go in and modify the package itself each time. So what we're going to do is show a script that is actually able to process business rules on the fly by using a type field to pick up from a database what rule needs to be applied, and then actually run that against the data. So this is not, for purposes of this demo, couldn't be made 100% generic, but still illustrates a lot of the concepts behind this. So we'll just flip back over to that. Go ahead and close that one. And we'll take a look at dynamic business rules. Again, single data flow, a simple source that's just pulling a list of products. We're going to process business rules, and in this case we have two outputs for it. One that are the valid rows that pass our business rules, the second output that is invalid rows that does not pass our business rules. So the way that that's set up, we have, again, the input that's coming in. So we're bringing in information about our products. We have some rules defined in the database that tell us what combination of product type and values for size, color, and capacity are allowed. So basically this says if the product type is a shirt, then sizes can be small, medium, large, extra large. If the product type is a backpack or container of some sort, then size is in liters instead of being small, medium, extra large. There's a range of colors that's available for certain types of products. So these are different ways of basically, it's the same column, but the range of values that is valid for it varies by the product type. So we want to basically be able to modify those lists of valid values in the database directly without having to come in and modify the package every time those change. So same thing here, we've selected the input columns that we're worried about, set the usage type on those. We have created two outputs in this case. So we have the single input, we have the valid rows output that is connected synchronously with the input. So what that means is here in the synchronous input, let me make this window a little bit bigger. The synchronous input field is actually mapped to our input one. This basically says for everything coming in on input one, I'm going to have the same number of rows leaving this component. However, they're not necessarily all going out on the same output. And the way you can tell that is through the use of this exclusion group. So if the exclusion group is not 0, then basically it means this output may have some of the rows, and there's another output that's in the same exclusion group that may have the other part of the rows. So the key thing is when you have inputs and you have outputs, each output gets marked as being either synchronous, or the other option you can choose is none. None is going to make it an asynchronous output, meaning that the rows that are sent down that output don't necessarily have any relationship to the rows that were received on the input. So some common patterns around that might be you need to perhaps aggregate some records. So you have 100 coming in, you're going to send 5 out that are the aggregated total of the 100 that came in. Well, in that case, you would use an asynchronous output. So you would select none here. And that lets you basically create brand new rows in order to send to the output. This is something you want to be a little bit careful with. Asynchronous outputs are slower than synchronous outputs, but in some cases they are the right approach, particularly again if you're actually changing the number of rows that you're processing within the component. In this case, we're using synchronous components because we're not changing how many rows come in from our input. We're simply changing which output they go to. So you'll notice this one, the invalid rows output has the same input assigned, same exclusion group. So this basically lets us say these two outputs are going to comprise everything that came in on input 0, the combination of rows. You'll also notice for valid rows, we don't have any output columns. We're just redirecting to valid rows if there were no issues. For invalid rows, however, we've added field name and error message, and this lets us actually say this is why we sent this particular row to the invalid rows. So let me make things small again. This one also uses a connection manager. So the script component allows you to basically provide a connection manager name that will be used inside your script, and then map that to one of your package connection managers. Generally, when you do this, if you want to keep things easy, you're going to want to use an ADO.NET connection manager, which is why in this case I actually have two connection managers at the package level, one that's an OLADB for using the OLADB source, and then a second one that's an ADO.NET. And this just makes writing the scripts a lot easier because the scripts are written in .NET using managed objects. When we interact with a managed connection manager through ADO.NET, it's much easier to work with those things than it would be if we were getting them back from an OLADB connection as an example. Then you have to do some actual translation of the object to something that you can work with in .NET. So generally you want to keep it simple and just use an ADO.NET connection manager. So I'm going to load up the script for this. Okay, so one instance level variable that we've got defined, which is the validation rules, and this is just a dictionary of dictionaries, a little bit complicated, but a dictionary is basically just a collection of key value pairs. You have a key for it, and you have a value associated with that key. In this case, a dictionary of dictionaries means that I've got a dictionary, I've got a keyed dictionary, a list of dictionaries, and inside of each of those values, I have another dictionary that contains another key, and then in this case a list of strings. This is what I store my validation rules in. So one of the things that we want to do with this, any setup initialization we need to do for our component, you want to put that in the pre-execute method for your script. Pre-execute runs once when the component's initially being set up. Anything that's really time consuming, generally you want to do here. You don't want to do initialization or setup steps within the process input row, which we'll look at in a minute, because that runs for every single row coming through. It can be very time consuming to do that. So really the only thing we're doing here is going out to our connections.business rules and calling acquire connection. This basically says go out and get a connection manager, or tell the connection manager to acquire a connection and return it. We're casting that to a DB connection. So this will work with effectively any ADO.NET data source, because they all have to implement the same common DB connection object type. We're creating a command that's basically the SQL statement. So we're going to a table in our database called production validation that gives us the product type ID, the field name, and then a comma separated list of valid values. We retrieve that as long as it has rows, which it should. Then everything's fine. If it doesn't have any rows, then we fire, in this case, not an error, but a warning just saying we didn't find any validation rules. So we're not stopping processing in this case, but we are letting people know that, hey, something seems a little bit odd. We didn't find any validation rules at all. So then we call the load rules method and then close out our reader, and we're done initializing. Load rules is basically just enumerating over the rows that we found, loading those into our dictionary, and effectively all the code here is just initializing it and making sure that we add the list to that dictionary of dictionaries that we had and assign everything to the proper values. So then on our process input row, we take the incoming row, we look for, do we have any rules defined for the specific product type that we have? So we go to the validation rules. Try get value is a method on the dictionaries that basically says look for a particular key, in this case the product type ID, and if you find it, return it in the whatever this out variable is, in this case, the rules object. If this returns false, if try get value returns false, then there's no rules. We can immediately just direct our row to valid rows because there's nothing to apply against it, and we're done processing. So that becomes pretty simple. If we did find rules, then it's going to keep running, and we're going to process the rule for each column that we're processing. In this case, the row size, color, and capacity. We're handling here just to make things a little bit simpler in the process rule function. We're checking each column to see if it's null, and we're defaulting it to an empty string if it happens to be null. And that just makes our code later a little bit simpler. Strongly recommend that if you are writing script components, you do actually check your columns for null, because eventually it will show up in your data, and if you haven't checked for null, it will quite likely break your script component. So if process rules returns true, then it's a valid row. If it returns false, so if it's not process rule, then it's an invalid row. We want to go ahead and direct the row to the invalid output. So we run through that for each of the columns. And at the end of this, if it's passed all the processing rules for each column, then we direct it to the valid output. And process rule is basically just taking the row that we're processing, that same list of rules, the field name. It looks up in that list of valid values. It's basically pulling that from the same dictionary that we populated at the first step. If there are no values, great, no validation for this field, return true, and we're done. If it does find an actual list of valid values, we're using another link function that basically says if anything in the list of valid values matches the column value, trimming off any spaces or anything like that, then we're good. We found a match. The value contained in the column matched one of the items in our list, so we consider this a valid value. We can return true. If we get to this point, it's because we did not find a match in that list. So we need to populate for an error. So what we're doing is setting the field name. In this case, if this was run for the size column, this would set it to the size value. And we would say the value that we found in the column, let's say if it's shirt sizes and somebody put in triple XL, then okay, that wasn't one of our valid sizes. So we would simply send an error message out that says that value was not found in the list of valid values. And we return false to ensure that the row is actually redirected to the invalid output. So let's go ahead and run this. And we can see the results of it. So on our, let's flip this around. We have valid rows on our left side and invalid rows on the right side. And the big thing that we want to look at here is our field names and error messages. So you can see in this case, we tried to pass some data through that had some incorrect size values. So it tells us that value wasn't found in the list of values. We had capacity that was incorrect, and some other size values. Other things like color was fine. We had matching colors for all the values that we were looking at. So this again kind of highlights how you can have a package that actually retrieves some external resources, uses those to make dynamic decisions about what to do with the data at runtime. And the nice thing about what I just illustrated is if you need to change the rules, you go in and you update a database table, and it becomes fairly simple to make your packages dynamic because the rules are being driven based on data that's being loaded. It's not impossible to do the same thing without using scripts, but it becomes a lot more complicated inside SSIS. Okay, just a couple of items left, and then we'll switch over to a quick Q&A session. A couple of quick tips and tricks. You've always been able to debug script tasks, script components have only supported debugging since the 2012 release. It is very slow and painful. I can't emphasize how slow and painful it is enough. So one of the things that you need to remember, if you put a breakpoint in process input row as an example, that breakpoint is going to get hit every time a row flows through. So if you're debugging script components, in general, you want to make sure you have a fairly small data set that you're debugging. Ideally, if you're looking for a specific problem, that you have data that represents that specific problem flowing through in your test environment. The other thing that you can do within script components is use fire information so that you can actually log the state of the component at various points, which can be useful to actually see what's happening. The other thing that you can do is look at the wrapper that gets generated. So I will show this very quickly since we're starting to run low on time. And of course, we'll wait for the scripting environment to come up. But when you create your script component, you get the main.cs. That's primarily what you work with. But there's also the buffer wrapper and the component wrapper classes. These are automatically generated. You shouldn't change these. But it can be interesting to look at it because you can actually see exactly how the component is interacting with the underlying data flow infrastructure. So you can see how it's getting columns out. If we look at the component wrapper, then you can actually see how process input row is implemented. They override the process input method, which receives buffers, which are collections of rows. And then it basically enumerates that buffer to call the process input row method. So this gives you a little bit of a taste of how the back end is actually implemented for the script components. One of the key things is if you want to do heavier processing, you can override process input and some of the other methods inside the script component. This lets you do some interesting things that can be much better from a performance standpoint. However, you have to be careful that you don't break other functionality in the script. So in a lot of cases, if you're overriding these methods, you still want to call the base implementation for the component just to make sure it still functions the same way. Performance-wise, script task, not a whole lot of concerns there. Again, you're pretty much in control of the performance because you're basically writing the whole thing. Script components are a little bit more complicated because the data flow engine drives how the component is executed. It calls the methods. One of the key things, as I mentioned earlier, process input row runs every time a record is processed. So you don't want to do anything heavyweight in there. There are things that look small that are actually very heavy, and particularly when you start getting into processing millions of rows, and a few extra milliseconds there can add up over the course of a full data load. Those things often that get people working with the COM interfaces that are exposed within the data flow. So those COM interfaces require marshalling back and forth between the .NET managed code and the COM interfaces. The more times you make that call, the more overhead is involved. So anything dealing with that, particularly if you're inspecting the collection of input columns or output columns, those are things that you want to ideally cache in your pre-execute method so that you don't have to keep incurring that performance hit. Keeping it dry, as I mentioned earlier, stands for don't repeat yourself. You'll find yourself doing the same sort of things in your scripts a lot. It's a good idea to use common functions, and you can certainly put the assemblies into the GAC if you have a lot of common logic. So coming up with some common libraries that can be used. And then finally, remember, scripts are great. I love scripts. I use them a lot. However, they're not always the best solution for things. You want to try to make sure that you use the built-in SSIS components, generally going to be the most high performance option where you can. Scripts, like I said, flexible, great for kind of specific tasks. If you're using the same approach in a lot of places, consider turning it into a custom task or component. Okay, And then a couple of resources. As I mentioned earlier in my blog, one of the best books on scripting. It's an older one, but still by far one of the best ones. Also written all in VB because that's all SSIS 2005 supported. But the Rational Guide to Extending SSIS 2005 with Script, highly recommended as a guide to writing SSIS scripts. Okay, and with that, I will turn it back over to Richard and see if we have any questions.
Thanks very much, John. We don't actually have any questions in the queue at the moment, so if you would like to ask any questions, please feel free to enter them into the Q&A panel. I did have a question. I've not used SSIS for quite a while, but I used to use something called conditional split when I was using SSIS. I saw you using the process rule. Is there any kind of massive difference in overhead or anything using a conditional split as opposed to a process rule?
Well, the process rule was a script that I wrote that's actually doing some additional work above and beyond just the conditional split. So
Right.
so if all I needed to do was make a decision based on a simple column value, I would use the conditional split. In this case, I actually needed to validate against a list of values, and I wanted that to be dynamic, not hard-coded, which,
Sure.
you know, with the expressions inside of the conditional split tend to be a little bit more on the hard-coded side.
Yeah, I remember it was quite limited from what I remember, but yeah.
Yeah. So in this case, I hypothetically could have written a script component that instead of actually using two outputs to say here's valid rows and here's invalid rows, it could have just sent everything down a single output and set a column flag that said this row is valid, this row is invalid, and used a conditional split to do that. But the overhead of doing it once you're already inside of a script component is fairly minimal. So, you know, if I was simply doing a conditional split, I'd use the built-in component, but this had additional logic in there, so that's why I just went ahead and rolled it in with the existing script.
Okay, great stuff. So we do actually have a couple of questions coming now. The first one is, can we make changes to those classes or will they be overwritten?
The classes for the script component that are automatically generated, if you see an auto-generated header at the top of the class, then it will be overwritten every time basically you reopen the script component. If you make any changes to the inputs or outputs, the component detects that you've changed inputs and outputs and it regenerates the wrappers. So if it says auto-generated at the top, don't make changes to it. That doesn't mean that you can't do some interesting things with overriding the core script component methods to alter the behavior of those wrapper classes, which would be things like overriding the process input method. There's a few other ones, create new output rows, which is used for asynchronous components. Those are all things that you can override in the script class itself that let you work around what the wrapper is doing in cases where you need to.
Okay, great stuff. There are a couple more questions, but I don't think we're going to have time to go through them all. One thing that quite a lot of people are probably interested in are these demos going to be available online? So are you going to blog these at some point?
Yes, they're actually, if you want to get them right now, they're actually already up on my blog from a previous version of this presentation that I did. But I will actually add a new blog post a little bit later today containing this set of slides and the demos from this.
Great stuff. Okay, so with that then, I'd like to thank everybody for attending Advanced Scripting using SSIS script tasks and components, and I'd like to thank you, John, especially seeing how early it is for you, for your time and your expertise. And again, I'd like to thank our sponsors, which are Microsoft, Idera, Dell Software, and our supporting sponsors, Pyramid Analytics, SQL Center, and HP. I really hope you enjoyed the session as much as I did. I learned a lot because I haven't used SSIS for quite a while now. Do follow along with us on social media. You can follow us at Pass24Hop, also at SQL Pass, and share your thoughts on the events with the hashtags #Pass24Hop and #SQL Pass. Stay tuned for our next session, integrating SQL Server Analysis Services with Hadoop with Edwin, which is going to be happening in a couple of moments. John, did you want to say a few more words about your session coming up at the PASS Summit?
Sure. So I'll be doing basically an expanded version of the same session. We'll be getting a little bit more into how to make your scripts reusable, which is kind of a common thing that comes up around them, as well as a few additional scenarios around making use of asynchronous outputs that we'll be able to dive a little bit more deeper into than we had time to today.
Great stuff. It sounds really, really interesting. Do you know which day yours is scheduled for yet?
Yes, I am the Wednesday afternoon. I forget the exact time slot, but I want to say it's roughly the middle of the afternoon.
Great stuff. Right, with that then, I'd like to thank everybody for attending today, and I hope you enjoy the rest of your day.
Yep. Thank you very much for moderating.
Oh, thank you for presenting. It was an awesome session.
Thank you.